Hey, good morning. Welcome to our Vicinity and Hammerspace webinar, aka webinar. Thank you, Rob, very much. On optimizing federal data management. My name is Lisa Ralph. I'm leading marketing over here at Vicinity, which means I get the special opportunity today to be the host. I'll introduce you to our stars of the show in just a second. You can see them on screen here already, but I want to run through just a quick couple housekeeping items beforehand. So first off, thank you for joining us today. We know it is summer. We know there is a million places you can be. So thank you for choosing to spend it with us. Also, we're technically booked for an hour. We're going to try to condense that a little bit. Make good use of your time. Everyone loves that. Second thing, this is a virtual webinar, obviously, but we're going to try to do our best to keep this conversation as engaging as possible. It will be a little bit of a fireside chat style. We were hoping to maybe have our speakers in smoking jackets, but it is August and that's not a great summer vibe. So we're just going to depend on your engagement, either through us being incredibly colloquial or you going through and engaging in questions. So you can actually, there's a Q&A tab. I know we're all Zoom gurus by now, but feel free to pop in questions. We're going to try to make this as conversational as possible. So as you have questions, pop them in. Otherwise, it's going to be left up to me to ask questions, which is maybe amazing or terrifying. One of the two. And then third thing, just because this is the one Q&A you can always count on, we are recording the session. We'll be sharing it out soon after the webinar today. So you can review, share with colleagues, whatever you need. So with that, we've survived the housekeeping segment. Thanks very much for hanging with us through that. And it is now time to meet our distinguished guest. So you've seen them on screen already. We've got an incredibly dynamic duo here today. I'm thrilled to introduce you to Steve Wallow, who is the CTO at Vcinity. Hey, Steve.
Hey, Lisa. Glad to be here.
Excellent. And Rob Ranzoni, he is the Director of Technical Sales at Hammerspace. So he is leading their U.S. federal sales team. Rob, thank you so much for spending your afternoon with us as well.
Oh, absolutely. Thanks for having me.
Cool. So for everyone on the line, you'll get to see a little bit of this. These guys are great, but what I'm really excited about here is they do a really nice job of translating between kind of being able to dig into the technical trenches as well as being able to bridge that to what's the mission goal, what's the mission outcome and value. So it should be a good conversation today. If you're trying to talk high strategy or if you need to geek out a little bit, I won't be a part of that party, but we've got that too. And then just in terms of what to expect, we're going to take a little bit of a different approach. So it's going to be kind of a chapter by chapter storytelling, talking about how efficient access to and control of the vast amount of data that today's government operations are grappling with, how really Hammerspace and Vicinity come together to put data and mission success within reach. So with that, we're not going to waste any more time in the boring part. We're going to move into the introduction or chapter one. So as a part of that, we will actually flip it over to our speakers, but Steve and then Rob as well. I was hoping you could walk through a couple things with us. One, kind of just an intro. Who are you? Tell us a little bit about kind of each of what Vicinity and Hammerspace are doing separately. And then if we can talk a little bit about how Vicinity and Hammerspace are coming together to kind of address this data accessibility and orchestration.
Sure. Sounds
Cool.
great.
Sounds good.
Alrighty.
Steve, you can talk about Vicinity a little bit.
Oh, sure. I thought Lisa was going to put up a slide there. I'm sorry.
Oh, do you see it?
I do now. Thank you very much. So yeah, apologize for that. So a little bit about Vicinity. This is a technology that was bred out of the federal workspace there, specifically the intelligence communities, national research labs, National Reconnaissance Office. But this is something that is in a lot of different mission critical programs. The genesis is the federal space. There's a pile of patents around this thing, a lot of different ways to put it together, but fundamentally it's something that was designed to solve some very specific problems that pretty much everybody has in the federal community in a little bit of a different way, right? So the lineage is from the Fed space. If you could hit the next slide, please. So here's what we really set out to solve, which is the fact that the data that you want to use is not usually where you need it to be to do something with it. right? Who's the biggest consumer of, IT information and data in the world? It's the US government, right? So the data is everywhere, and moving it around becomes problematic, right? There's perishability with data, right? Sometimes it just takes too long to move the data. By the time you get it, there's no more value, right? And the other thing is, what happens if I need to keep that data in a pristine state, right? If you look at the old kind of traditional approaches to solve these problems, one of them is kind of WAN optimization, which is not what we are, but they're usually involving something like compression or dedupe, where I'm going to make the data look smaller so I can move it faster, right? The problem there occurs, and this is kind of where Vcinity was created, which is, well, maybe my data is encrypted, or maybe there's no compressibility with the information. Maybe it's 4K video or something like that, or maybe I don't want to mess with information because I'm using things like artificial intelligence, right? I always use an example of, let's say you had a video image, back in the day, you can move that video image around, give it to an analyst, a human person there. And, if a bit got changed here or there, no big deal. However, now with the AI and some of this big horsepower, one little manipulation of the bit can make a big difference, right? So people want that pristine copy of information. And also, if you take a look at some of the other approaches, it's about predictability, right? Maybe I'll look at your usage patterns and try to figure out, well, okay, I think this is what you need. So I'll move it ahead of time, and maybe when you get in the morning, you have some coffee, your data's there, right? Well, those things start to fall apart if my data is too big to move or it changes too frequently, right? So this is the challenge that we really set out to solve. And the last thing I'll mention here, it's how do I manage all this information, right? Vicinity is really good. I'm going to show you what we do about kind of gluing all this information together over distance. But I still have to be able to manage it, right? I have to figure out where do I need what, when, where, how, and why, right? So we're going to talk about that. That's where we bring in Hammerspace. So if you go to the next slide, everybody wants to know about AI. Okay, how does this help AI? I want to dabble my foot in the AI waters there. What are some of the big challenges? From our perspective, it's really this kind of triad, right? The first one is I got to train the models. And this is kind of the biggest problem, the first challenge that people get into when they start looking at AI, which is I have a lot of information. It's somewhere else. It takes forever to move that back to, the major compute that's going to do that training. So, if I can speed that process up, if I can move information faster over distance or in a shorter amount of time, then I'm able to train my model more effectively, more information, more accurate, quicker in time, right? In the middle there, you see, okay, this thing called hallucinations, right? What happens there? I always tell folks, I'm looking for a tank through my model, and then I run it and I point it to something, and then up with a goldfish or something, right? I need to be able to tune that model, and that usually involves getting access to information more in real time. Right? I want to do RAG. I want to do edge inferencing, right? There's a constant push and pull that goes back. I don't create a model and then just throw it out there and be done with it, right? There's this constant iteration of getting new information in near real time, right? How do I solve that problem? And then the last one, especially in the Fed government space, right? I want to have the agility so that I don't get locked into one particular maybe data center location or a cloud. Like, the last thing I want to do is say, okay, I would like to use a cloud. It's all good, and then all of a sudden something changed and I picked the wrong one. So how do I have the ability to pick the resource that makes the most sense for me to use? So what do we do? So on the next slide, this is kind of what Vcinity brings to the equation, right? It's kind of this two-component piece. One is, can I move information a lot faster over distance, large geographies? Yes, you can. But the other one is, maybe I want to be able to access it in real time. I want to do remote access, where maybe I don't have to move the information. Maybe I can just work with it over distance. It's a completely different approach, and that's kind of what we bring here. And if you look at, kind of the outcome here, one, it's a global solution here, right? We wanted to be able to extend to anywhere around the world that the government has resources. The other one is, and it says here, immediate usability of next gen. I don't want to make something that requires a specific type of network or compute or storage or have to rewrite applications. We want to bolt on to the existing infrastructure you have, but also give you the flexibility to grow with it, right? That's one of the things we came up with. The other one is, the centralization of edge data, and that's a logical construct. What that means is, I want to be able to look at all that information and work with it as if it's all sitting in a common area with the performance as if it's all sitting local, right? And then the last one here is, I want to create a tunnel, but I want to do it without any modification, right? As we kind of alluded to before, manipulation of data becomes a problem. So this whole solution was created without touching the data, right? This isn't about compression. It's not about dedupe. It's not about any sort of data manipulation at all, keeping that pristine copy. But what it doesn't do is manage the data, right? Vcinity isn't designed to say, okay, this is what we have from an intelligence perspective to pick and choose what we need where. That's why we partner with somebody like Hammerspace. So Rob, over to you to talk a little bit about what Hammerspace is up to.
Yeah, thanks, Steve. And that was a great intro on Vcinity there. So I'll give you a little bit of background about Hammerspace. Our founder, David Flynn, had previous success at Fusion.io, bringing high-performance SSDs to the market, and really building $1 trillion industry out of it. Since then, during that journey, he kind of found out that there were some inherent challenges with centralized IT. And Steve touched on a lot of that is, how do we start mobilizing data assets? Data tends to have gravity, and if it's in a centralized repository, it's really hard to get to, especially when we start looking at things like edge processing or edge AI, where data is distributed all over the place. If we look at the latest Gartner reports, they're saying 50% of data analytics will happen at the edge. And that means the other half is still back in central IST. So there's inherent challenges to centralized IT, and there's some challenges around decentralized IT. And I feel like if you've been in IT long enough, you've seen that wheel go round and round a few times. I think what Hammerspace was created for, and I think this aligns with what David was thinking, was how do we create a unified capability, an orchestration layer that allows data to be fluid and dynamic and more unified, so that you have these disparate systems from various vendors on the edge connected to a central repository, and everybody's working off the same sheet of music. And that's ideally what the foundation of Hammerspace is a unified global namespace at very high performance. To do that is not an easy task. So we've been in business for about 9 years. Creating a file system from scratch, it just doesn't happen overnight. A lot of folks have tried to build a global namespace and failed. We've put a lot of R&D investment into this. We've hired the right people. Like our CTO is Tron Mickelbus. He is a maintainer. He has been a maintainer for the Linux code for, I think, over 2 decades now. On his staff, we have some other Linux maintainers. As you see, as we get into the nuts and bolts of what Hammerspace is built on, you'll understand why having maintainers like that on staff are key to everything we're doing and everything we're contributing to the open source environment as well. Beyond that, next slide. We could talk about this. What does this look like? What does this concept look like in real time? And as Steve spent a lot of time talking about how to accelerate data movement across the plane, he did say something about data management. And when you think about Hammerspace, don't think of it as a data management, because traditionally data management required lifting and shifting data or cut and copying data from silos of infrastructure and placing it somewhere else. And that all happened outside of the infrastructure. So you needed an application that was doing this. Data orchestration is a whole different concept. It's actually everybody's working off of that same unified namespace. It's inherent to the file system now, and everybody can just see their data. So in the case of Blue Origin here, they had on-premise hardware and they had a desire to build a hybrid infrastructure. In the old days, each of these locations, the 4 different locations, were silos. They didn't see each other. If they wanted data from Florida to get to Washington, they had to replicate the data, made copies of that data. It became very cumbersome and burdensome on the overall architecture. They dropped in Hammerspace. They put it on top of the existing architecture, which was built on Cumulo, but we can pretty much work on any NAS-based system. Unified the environment, so now when a rocket is launched in Florida, the folks in Texas have live visibility into the data assets that are being generated in Florida. And if they desire to have access to that data, they can make an instance of that. They can get an instance of that data live. So everything's now happening in real time. They've accelerated their workflow. And of course, they had, as a lot of federal infrastructures seeing, we're moving workloads to the cloud. Well, in this case, they just added cloud as an extension of their existing systems. There was no lift and shift to the cloud. There was no debate of whether I had to be in the cloud or not be in the cloud. It was just an extension of what they already invested in from a hardware platform. The agnostic approach that Hammerspace brought to market allowed them to do that. We can easily have, a NetApp system in Florida and Isilon in Texas and Cumulo in Washington and create the same effect. And next slide. And although there are other vendors in the market that create global namespaces, they tend to either do it on proprietary hardware, where traditional storage vendors are always like, here's my product, my hardware stack with my file system, and buy more of my product and just grow it that way. That becomes that vendor lock-in that Steve was discussing earlier. We tried to avoid that, and by allowing Hammerspace to live above the existing architecture and creating an abstraction layer, we can replicate the metadata from site to site to site to site, all the way out to the edge. Everybody's operating on the same unified pane of glass. And then below that surface, decide what storage asset the customer has and how to utilize that in the best fashion. And this is a break from traditional, in the high performance computing space, the traditional model was to tier data downward. Instead, we're doing data placement across. And we can do that data placement within the data center from high performance disk arrays or SSDs down to lower cost object storage or S3 buckets, and then distribute that even further and go globally with that. As these two yellow boxes indicate separate POSIX locked file systems at two different independent locations, and we can do this at a scale, a tremendous scale globally. Next slide. No, one other piece on this that I've overlooked is going back to those maintainers, the CTO. Everything we're doing is built around a true parallel file system. So we're leveraging NFS 4.2, which has a very high performance, low chatter capability to it that allows you any Linux application, any application really, to access the underlying storage at very high performance, which later in the show we'll show a demo of this and live editing. Next slide. So as the concept, I'm seeing this a lot with my government customers, is the desire to integrate the edge with the core and not have disparate systems at the edge. And to do that, there's two pieces that need to be solved. There's the how to move things across the wire faster, and that's where Vcinity is tremendous about getting data from point A to point B, whether that's on land-based systems or even bouncing things off of satellites. We've worked with some entities that want to do things like that. We come into play on the orchestration of that data asset. So we're not copying data. We're not doing data management per se. We're giving you the ability to unify your data so that as the assets on the edge are generating data, the analytics can happen real time at the edge, but also you're not missing out on the component of the commanders back home seeing that data, seeing the visibility, and having a say in the data processing. It's just a more seamless way of unifying everything and allowing everybody that needs to have a say in what happens with those data assets to have a say in real time, instead of lifting and shifting, or in the old days, even loading up a cargo plane with disk arrays and sending it back home, right? It was very painful. So this is this is core to everything we're doing. This is core to the partnership with Vcinity. There's some nuances in the architecture that we'll get into that make this very crisp and clean. We can do this in a contested environment where the bandwidth may be going up and down, whereas some of the other folks, you can't do that. When they do a global namespace, they lock everything down. And it's very hard, and that just doesn't happen for DoD. So next slide.
A lot of flexibility there. So you guys, and you mentioned the putting on trucks and C-130s and all that kind of stuff. It's amazing because we still see people doing that. It's kind of funny in today's age. But from an AI perspective, there's a lot of, I like the clarification on the orchestration as opposed to just the traditional management, which is kind of cool. But from an AI perspective, what are you seeing as a value prospect of people that are looking for that in their journey?
That's a great question. And there's two components to the AI equation that's being answered right now. One is the infrastructure. And if you look around, federal in particular, they're a little slow on adopting the infrastructure. We're seeing an arms race on the other side. One of our big customers is Meta. They've published blogs on what they've built as far as leveraging an open source, open standard kind of based file system like ours with a parallel NFS to optimize data performance and get data from the GPUs down into the storage nodes. The other aspect of this is how do you mobilize that data? Because there's just not enough power to put all the GPUs in one location. No matter how good your data center is, how big it is, you're going to have to distribute data because GPU resources are going to be global, and the smart guys in the room are going to mobilize their data assets and unify that so they can take advantage of cloud capabilities that are out there, or take advantage of taking 5 data centers, unifying them under the same umbrella, and having a lot of GPU power now, and across various GPUs as well, because NVIDIA is the leader today. But we all know it's not going to stay that way forever. The market's going to dictate more chips come available. So the other component, just one last piece on that, is tying in the legacy systems. In order to train a model, you really have to tie in all these legacy data pipelines. And how do you get the legacy disparate systems into the model? And that's a big challenge. And I think Hammerspace solves that.
No, that's interesting. And you're spot on with the GPU placement, because you could put it all in one spot, but then is it the right spot, right? Who can get to it, and how do I manage all the stuff that's trying to feed that, and where is that located? So yeah, it's a common problem. Interesting take on that. Cool. Yeah. So just on this slide here, I'll add a little bit of we saw this in the beginning. This is something that we alluded to from the Vcinity. What are we trying to solve for, right? And I think, as you can see, between the two companies here, we've created a pretty good architecture for solving those challenges, right? Which is, my data is everywhere. How do I virtualize it? How do I orchestrate it? How do I make those decisions? And how do I do that all in real time? And Robbie brought up a good, interesting point, is regardless of whether it's on terrestrial or it's in the sky, right? Because if you think about a lot of the information is just hopping between satellites up in space. So we're kind of creating this information exchange in space, not just going up and down between the two, right? And between the two of us, I think, we really don't care what that looks like. It's whether it's a spacecraft for storage or satellite or networks in the middle, right? The idea is to have that agnostic feel to working with whatever you got, wherever in the world that is. So
yeah, I think COVID poured gasoline on that equation. Right?
Yeah,
we all saw everybody went remote all of a sudden, but your data was sitting in a tower or a data center back home at the headquarters. And how do we distribute that and fix that problem? This architecture, this infrastructure between the two companies would really come up with a way to make it seamless, right? It just doesn't matter what you've already invested in. You can just plug and play and go.
Yeah, no, I like it. Next slide, Lisa. Thank you. So, I kind of at a high level piece, some of the things that I noticed on this slide when we were putting this together, over the last couple of days, the mission agility, right? Nowadays missions have to have the ability to flex, right? You want to have, if you're locked into a particular process, that's all well and good because it's repeatable, it's deterministic, but sometimes the mission is not. And having the ability to say, look, not only can I adjust from, where my resources are, where my data is coming from to accommodate any changes that are happening in real time, that's an extremely powerful piece. And I think the joint solution we bring gives that visibility, gives that hook, so that, yes, you want repeatability, but you want to be able to, move in a different location very, very fast, accelerating times to insights. I want to be able to see what's happening, take that information, assimilate it, do something unique from an execution standpoint. So, those are some of the couple things that I took away from this particular piece here.
Absolutely.
Cool. Okay.
Thanks.
Oh, demo time. Okay.
There you go.
You want to see a demo? Let's go ahead and do this. Okay. I got to put my glasses on, or as we're going to be working.
Hold on, and I'm stopping sharing 1 sec.
Oh, wait, not yet.
Okay.
Okay, so here's yeah, thank you. So here's what we're going to do for the demo, right? This is a joint demo. The way that we're going to show this is we're going to show a comparison. That way, when we do something and you see it, you're like, well, is that good or bad, right? So you're going to have some numbers there. We're going to show a comparison so that you have a baseline to see the improvement, to see the agility, to see, what we can do is possible that wasn't possible before. So the way the demonstration is set up is that we have Hammerspace out in AWS West, right? They're managing a big storage pool. They virtualize the whole thing. We're going to go ahead and hit that over distance, right? And that distance would be from Amazon on the East Coast. Now, all of our technologies work with all the different clouds, all the different networks. We can do anything you want, but this particular demo is set up using AWS. Okay, so just everybody has that. It also is showing a data flow going from West Coast to East Coast. We could flip that. We can do different things. You know, you can pull data from the edge back into the kind of the Hammerspace hub there. Or for this demo, we're changing up a little bit. You know, we're going to pull data from the hub, maybe out to the edge. Maybe we're doing some edge inferencing. We're going to load the models in. You know, it's a constant iteration. But for the demo, we're keeping it pretty straightforward and just kind of moving in one direction here. Okay. What we're doing from a client perspective, we're going to do something with video. Rob kind of alluded to it. We're using Adobe Premiere. You know, both of our applications our companies, we don't care what the application is, right? We're application agnostic. We're storage, networking. What's kind of cool about our joint solution here. For this one, we're using Adobe Premiere. So I'm just going to do some stuff with video. You're going to see that. But what we're really showing here is two things. One, we're hitting a Hammerspace environment that they're managing, they're orchestrating. I don't have 30 different cloud locations. That would be kind of cool in a demo to do some neat things like that. We're just kind of hitting one, but we're also doing some stuff from the vicinity perspective and doing it over distance. Okay. I have two windows. Hopefully you can kind of see the difference here. On the left side of the screen, this is that traditional client that we logged into. And on the right-hand side of the screen is the Vcinity version. So the only difference between the two clients is, at least from a Vcinity perspective, we're just tunneling through our software in and out of the door to get some unique capabilities of extending things over distance on a high link connection. Okay. The way the technology presents itself is there's standard files, folders, and shares. So that's what we've done. So what you're looking at here in the window is I just created a network share and I pointed it to the remote Hammerspace environment. So what you're looking at here is from the East Coast, I have this folder here, and what that folder is showing you is the Hammerspace managed environment on the West Coast. Okay, so we're going to do two things. I'm going to show, some ability to do things over distance, but also what we're going to do is show, from a Hammerspace environment that, their solution doesn't slow things down, right? Want to make sure that, they're creating this great value prop there. One of the big problems with some of the other ones that are out there is, I can do things with it, but the performance is horrible. Hammerspace has done a very, very good job of creating a high performance architecture that gives you the values that they bring. From the Vicinity perspective, we're taking advantage of that over distance. Okay, so what I'm going to do first.
Bring that in, Steve.
Yeah, go ahead, please.
One customer that we accidentally stumbled into a solution was we had a customer in media and entertainment actually that was they wanted a global namespace. They wanted to go global with their data and whatnot. And by chance, they happened to be sitting on legacy Isilon infrastructure. We put Hammerspace on top of that. And by a byproduct of implementing the global namespace, the Isilon was able to do double their compute power.
Wow.
They didn't put any more hardware to the stack. They didn't add more power there. It just happened that because of the parallel nature of what we're doing with PNFS, it was able to parallelize the writes into the data flow, and away they went. So it was just a kind of a side benefit, but it enlightened us to what the power of PNFS really can do in these environments. It's not
right.
Your mind goes to, oh, I'm adding an abstraction layer. It's going to create latency and slow things down, but it really is the opposite. It's a superpower of having parallel.
Right. No, I like it. We need to get a Hammerspace little superhero kind of.
I have my
Vicinity on one side, Hammerspace on the other, right? That'd be kind of cool. So let's show it, right? So here's what I'm going to do. I'm going to take what I have here, a bunch of files. I think they're 5 gig. We're just going to just drag and drop from, we're going to pull it from the West Coast in this case over to the cloud on the East Coast. I think it chose number 10 here. Yep. And what you're going to see, so on the left-hand side, traditional approaches around about 15 meg. On the right-hand side, 160 something megs. So, again, one side of that value piece that we were talking about, which is, hey, if I need to move data from A to B, right? Vicinity is going to help, do that within the Hammerspace virtualized environment, right? We're going to kind of put that data transfer on steroids. You can see it here. Very impressive. And again, from a training perspective, right? What's this mean to AI? What this means is, I can move a lot more data in a shorter amount of time, or I can just get the pieces that I want faster, right? So, training that model, bringing it in, pulling it into the virtualized orchestrated environment from Hammerspace, that's kind of a really cool joint product. Everybody gets it. Everybody has this problem. That's an example of how we solved it kind of live here. What we do now is we're gonna do something with that video, right? So I promise we do this. What I have here is Adobe Premiere, right? So what we're gonna do is I'm just gonna play a video, and what I'm going to do is I'm just going to pull it from the Hammerspace environment. So I have some HD videos here, some drone footage. I'm just going to drag it into Premiere here. And again, remember the Premiere application compute is on the cloud on the East Coast. but the data is in the Hammerspace environment on the West Coast. Okay, so we're doing some kind of unique things here. Normally, people wouldn't try to do this with a video. It would be a horrible experience. In fact, I'm actually going to show that. Right, so I'm going to come over here to the Vcinity side, take the same video. I'm just going to drop it into the window there. Okay, now what I've done is I've turned on, the term is called dog ears. What's important is I put some math behind this. Right, when you start working over Teams or Zoom or whatever in the world we're on here, you know, it has a tendency to kind of show some jitter when it really isn't there. So in the middle here, you see some numbers. It says total and dropped. That's actually the frame count. So we're gonna let math define how good this works. I'm just gonna play the video. So we'll start on the traditional side, and you see the total going up, and then of course, there you go. You see the dropped frames, and then pretty much dropping every frame that's trying to go over distance, right? If I do the same thing on the Vcinity side, now remember, it's not just what we're doing from the networking perspective, it's also that, you know, Hammerspace has to be able to keep up, you know, with these requests. And if you look on the right-hand side here, my total's going up, but I'm not dropping any frames, right? And, you know, when you're able to do this over distance, connecting to a virtualized environment with the performance and the flexibility that, you know, that Hammerspace brings, this is a pretty cool joint solution. So again, something kind of interesting to show. Rob, anything else you want to add to this?
No, I think you nailed it. It just works, right?
Yeah.
It doesn't have to be just AWS. You know, we have customers that are running multi-cloud, right? They're hiring people all over the world, and they're standing up cloud instances to do live editing from wherever they want to. And the smart guys are using spot-based pricing, right, on the cloud, and saying, well, it's cheaper to do my processing over here. They click a button and they're away they go to a different bucket in a different cloud vendor. So that would be the other differentiator we have here is the true agnostic approach to this.
Yeah, no, I agree 100%. It's interesting you bring that up because, you know, I asked a couple of our engineers to spend the time to put this together. And when I was talking to them this morning, I'm like, okay, we're good to go. They're like, yeah, it was pretty easy. It took us like, you know, half an hour, 45 minutes. We had the whole thing up and running between two different clouds. So that's a good test, you know, the flexibility of what this thing is bringing. So back to you, Lisa. Thanks for letting me show a demo.
I wanted to just quickly recap before we move over into more of a conversational chapter. You guys were talking a lot about, hey, one of the biggest issues is that so many of these governments have distributed locations, they have decentralized data. Is there anything or kind of, are there any dependencies for Vcinity and Hammerspace, as you just showed this example, in terms of particular data types you need to work with, particular storage types, different locations? Kind of, you mentioned terrestrial and sky.
Sure, Rob.
I think, you know, like I said, we're agnostic to the platform, so we really don't care about the hardware. We've disconnected the file system from the hardware, and that's important. As far as data types, we tend to we focus more attention on the unstructured data assets because those tend to be harder to move around the globe. We're not, you know, you think about open Dropbox or something like that. That was a great tool for enterprise IT maybe, but not necessarily for moving ISR assets around the globe, right? It's a totally different mindset.
Mm-hmm.
So we can work with anything, but that we tend to focus in unstructured.
Yeah, good point. It's interesting because, you know, just like yourself, you talk a lot to federal customers, and, you know, the infrastructure in some cases is very old, right? It's got to be very, very flexible. And the last thing you want to do is come in with this great solution. They have to forklift and change half of their architecture to make it go, right? So you want to be able to work with what's there just as a bolt on, as you mentioned, just kind of a layer on top, right? But not slow down the performance of it, which is kind of cool. And then be able to have that flexibility. So as they move into different things, they want to go to a GPU architecture or whatever, you know, that's okay. You can just keep adding different components to it. The last thing I'll mention is, you know, just integration between the two of us, right? You know, it's just mount points between the two of us. So the integration, there was no code changes on our end, no code changes on the Hammerspace side. It just kind of bolted together naturally, which I think was, you know, a good testament to both of the architectures. So yeah.
Yeah, and that migration is a real pain for customers, right? As we, you know, I talk to various entities, and they're talking about data center consolidations, and you know they have to connect all these disparate systems together. One of the secret sauces of Hammerspace is we don't migrate data necessarily; we assimilate it. So we can actually come into an existing architecture, scrape the metadata, and create the metadata abstraction layer, and then from there, away you go. So you really could turnkey this in less than an hour. And
Sure.
I hate saying those kind of things because people are always like, no way, but I've seen it in real time. It actually works.
Yeah, yeah, no, I have as well. And that's a good point about the assimilation, because then, if somebody can't move the data for whatever reason, but you want to have that view, this is an alternative, right? Or
Yes.
some cases you have stranded data just because it can't move. So what do you do with it? Right. So this is a good approach. Yeah, interesting.
Absolutely.
Yeah,
Cool.
and then another point that you guys have been making too, just in terms of, hey, not only is there kind of the technical assimilation across your platforms, but that also minimizes the amount of, say, workforce training or retraining and disruption to processes. So you can actually start seeing those results right away because you don't have those lags.
Yeah, good
Absolutely.
point. Yeah, it's funny because we do a lot in I'll pick on the DoD, right? They train people up and then they get redeployed as soon as they figure out what's going on, right? And if I can get somebody to just work with, an interesting environment that's folders, files, and shares, and people recognize and understand it, it's simple to use and easy to understand. The operational cost to put it in and keep it going is small, right? Yeah, good point. So, mhm.
Okay, so I'm going to hopefully share in just a second. Bring this back. Here we go. Okay, so that's great. So now that we've got kind of a baseline of who is Vicinity, who is Hammerspace, what's this joint solution like? I would love if you guys could give a couple examples. You've said, hey, we're pretty much agnostic to data types, to storage types, to locations, whatever it may be. Very exciting solution. Do you have a couple examples of how this is seen kind of out in the wild? And Rob, maybe you can
Of
go first.
course we do.
Yes, phew.
It's like next slide.
Uh-huh.
So this next use case, this is right in our wheelhouse. This is a challenge the DoD is facing today. As you go downrange in theater, the bandwidth goes down. It's not as accessible. The data is not accessible. Most of the data processing and analytics is happening back home, stateside, within the high performance computing environments. And that's great, but you got a guy driving a Humvee down the road and there's an IED that the supercomputer just identified because it has the data, and we just can't get the data out to the edge fast enough to save that guy's life. And that's really a technological miss, because the technology exists to solve this problem. And part of that is moving some of that AI processing, that traditional HPC workloads closer to the edge, where there's a little bit more bandwidth available, so you could do some of that data processing and movement, and then be able to send a signal, because those guys on the edge get a text message. They don't get to see much more than a text message, so you're really low on bandwidth out there. So you can see where the two components of Hammerspace mobilizing the data and Vicinity accelerating that mobilization really solves this challenge perfectly. And it's just not applicable to just DoD. I mean, I've worked with, USDA, they have, or EPA, where they're going out to the, marshlands where there's no bandwidth, in the middle of nowhere, or even healthcare with the Navajo Nation. There's not a lot of IT infrastructure in some of these places. And having the ability to create this and unify this really solves the problem quickly.
Yeah, I love this chart. I'll give you an example from our perspective. We work with one of the customers that is collecting information. It's a big sensor platform, right? And the problem that they're having is, they can collect tons and tons of information, some high def cameras and all the other different sensor types they have, but everything they collect has to be moved back, and they can't get that all moved back in the time frame that they need. So unfortunately, the answer is, well, we'll just turn down the resolution of all the sensors so we don't collect as much information because we're required to move it. And that's really, it's a horrible thing, because, you want that pointy edge of the spear to have that, the intelligence, the detail, those types of things. You want that, and it's a shame that you have to sacrifice all of that just because you can't move the data fast enough, or you can't see that fast enough. And that really goes to this point here, which is most of my information is being collected at the edge in some cases, right? And if it's, kind of disabled in terms of bandwidth or something, that's a problem, right? And let alone being able to see it and view it and do something with it to make intelligent choices. So yeah, I love this chart. Good stuff.
And this is more or less a recreation of that, but with more technical detail to it, because one of the big initiatives underway, we see it with JADC2 within the DoD community, is how do we enable multi-cloud? We're no longer just standing up a ginormous instance of AWS. We need to leverage all cloud capability all over the place, and that poses a lot of challenges. And you have your your disconnected edge sites that are traditionally, hardware infrastructure. You have these cloud environments. How do we create this unified visibility, this view of data assets? And we truly, with this, can take one application and attach it to all storage resources. So that there's beauty in that, because now the mission can actually operate with an abundance of resources, no matter where they're at, if they're at float or whatever. And I think the acceleration piece really plays hard in this, because not only are you accelerating the data, but we all know those lines don't stay up all the time, especially if you're on a Navy ship out in the ocean or a Coast Guard cutter. Sometimes you have connections, maybe you don't. Sometimes your base gets blown away and you have to pivot to another data asset somewhere else. And we've truly proven out a concept here where we can support that kind of capability.
Yeah, it's a good point. It speaks to, you want that resiliency, right? When you into the DIL networks, the disconnected intermittent types of networks, being able to kind of see that and work within that environment to get information faster, in a shorter amount of time becomes life-saving in some cases. One comment on this from the edge AI processing, it's kind of interesting, edge AI is becoming more and more popular, but usually don't do that just to have maybe a small factory or something, but you usually want to take those results and do something with them. Right, you want to give them to other edges. You want to give them to the mothership. So having that visibility and connectivity is really important. But I'll give you one example, and it really points to kind of the namespace that you guys have created. The ability to see that, because what people were doing, let's say you have 3 edges here, they would say, okay, I'm going to curate and do some AI at this edge, and these are the results that I've got, and then I'm going to push those back because I think they're the important pieces. And they did that for each one of the 3 edges. But it wasn't until they looked at as didn't look at each one independently, they looked at the holistic piece across all the edges through a common namespace environment, that they could see things that if they looked myopically at each one, they couldn't find. But when they backed off and looked at everything, they realized that there was common features they were missing in the curation process. And it wasn't until they had that global view that they were able to actually see that. So, kind of a cool thing here. I like it.
Absolutely. Yeah, and if you think about weapon systems, they were traditionally designed and built in silos, right? You buy the product and you go and shoot the rocket. That's not the world of the future, especially with the advances in AI. The guys in the Army that are shooting rockets are going to want to talk to the guys in the Navy that are also shooting rockets, and they want to hit the same targets or different targets, so they're not wasting resources. Sure. So giving the battlefield commanders a unified view across the DoD entities is huge in this aspect. And I really, I'm encouraged to see what's happening within the DoD in their mindset and their trajectory on this. It's really cool. But as you can see, and I don't have my glasses on here, but those edge components tend to be different. We partner with a numerous amount of hardened edge devices out there. They range from small to large. You look at Dell. Dell has a relationship with Tracewell that does ruggedized edge components, and we've integrated with them to help alleviate the pain on that platform. But then there's these new boxes like from Source Code that have lots of GPUs in a TSA size suitcase, and they're actually really mobile computers, mobile data centers at the edge with lots of data. I mean, we're talking 1.5 petabytes to 5 petabytes of data that needs to be processed, but also utilized, like you said, back in. You want to give everybody a view, and it's great that we want to give the edge such empowerment to process and do things and make decisions, but you don't want to leave out the traditional guys back home. The boss needs to see your work, right?
Right. But you guys bring up a good point is, from our perspective, the information exchange has to go both directions. And I'm sure you guys have the same thing. Regardless of where you are, you can get the same kind of view and do things with it. But I'm sure if you can comment, you can control probably who can see what, where, when, and why. You don't just want to open up the kimono for everybody to do something with, right?
Exactly. Yeah, that comes into the orchestration. You get to decide who gets to see what, where. In some cases, maybe you want to do more of a hub and spoke model. Others, you want to have a unified data mesh. It's very flexible in design. You can even do data staging. We have some use cases where customers know they need certain data assets to be staged out on the edge, and you can do that via policy to actually push data to wherever it needs to go.
Very cool.
Yeah.
Excellent. I'm being mindful of time. So now we've got a sense of kind of the problem, the solution, some of the ways that could be applied, but talking a little bit about actually making that go. So I'll just leave this picture up here so we can think about something in the background. But in terms of best practices, Rob, you've probably got a lot of examples of this, and Steve as well. But as you're seeing kind of agencies or different clients going to say, hey, this is going to be our first implementation, what kind of deployment pitfalls are you running into, or what kind of learnings can you share in terms of how to make sure that you've got mission success from the get-go?
I mean, beyond the politics of it and trying to get multiple, entities and have different budgets to unify.
Start with the tough one.
Beyond that, there's the technological limitations. There's a lot of network out there that isn't it's either overtaxed already or just not in place. And I think that's the beauty of what Vcinity is doing, to alleviate some of those challenges where I'm coming in and saying, hey, I can orchestrate all your data. And they're like, I got a 10 gig link. It just does, you need both components there. The gotcha that I run into, our best practices, is when you're looking to deploy a global namespace, and a lot of agencies they're either doing the hub and spoke or the true global namespace capability, is the other vendors in the market are all doing global locking. So that means when a user like myself is editing a video file, the rest of the world is locked out. They can't do anything with that. And if the network goes down, the visibility goes down too, and you become an isolated, instance that's doing your own thing and it's not synchronized. By accidental design, I'd say, Hammerspace went with a non-locking global file system, and there's a lot of benefits, especially for my federal use cases in these environments where each of these yellow boxes you see on the screener are separate POSIX locked file systems. And when the network goes down and it comes back online, we just resynchronize the metadata and away we go. And this, lends itself well to the use case. It's a fundamental architecture design though, and it's not easy to overcome for the other vendors in the space. So I think that's a best practice.
That's a huge power move on your end, because that's extremely important. That's
totally accidental, I think.
Well, I can't say that, but it's impressive. It's very impressive. From our end, I'll look at it a different way. Because both of our companies are agnostic to so many different things, right? You don't have to require certain things, right? We're working with so much that's out there. One of the best practices I always tell folks is to think differently, right? I mean, we can talk about scalability and clustering and technology, but plan on doing things that you didn't think was possible before as you move forward. Right, you have to think about the problem differently because now you have a completely different set of tools, right? And that is a best practice. Not to say, hey, I have this cool technology, I'm going to do the same thing. No. Right? You utilize and take advantage of the different things that are possible as you move forward. So it's kind of a different approach to this best practice thing. But yeah, good question.
Cool. And then actually related to that, maybe we're thinking ahead, but talking about, hey, we've gotten through our first deployment. Now we've said, it's amazing. We've got to do more of these. And likely as we see our missions are changing, the locations are changing, the applications or clouds, whatever it may be. How do Vcinity and Hammerspace help you plan for the future? Why is this valuable to have?
From my aspect, it's the vendor lock-in. My traditional background is storage. I've been in storage for my whole life. Every storage vendor does the same thing. I'm faster, I'm lower power, lower cooling. I'm the new whiz bang kid on the block. And when I chose to change my job, I loved what I saw at Hammerspace because of the agnostic approach to this. To Steve's point, it's a fundamental change in how you think. You're not just going out and buying more controllers or more JBots to grow your storage. You're looking at it from a different view. You're really, now have the empowerment of a global namespace, and you can decide what kind of storage you want. So we're really empowering the customer to, pick and choose the hardware platform because now they have the software in place to do it. And it's cool.
Yeah, no, I agree 100%. I mean, drop the stuff in that allows you to grow based on what your mission needs and have the flexibility to make that choice on your own, as opposed to just being forced into something, and then next thing you know, it was a horrible choice years ago, right? You want to get out of that kind of mentality. So,
or it was a good choice. I mean, there's perfectly good systems out there, but the world changed and we have to evolve. And procurement changes too. That's the one that usually gets the customer, right? I know some customers have 7 different vendors on the floor, and because it was different procurement cycles, then lowest bidder wins sometimes.
Sure.
Mhm.
It is what it is.
Cool. Okay. I'm trying to be mindful again of time. We were a little bit chatty. So what I'm going to do now is actually move us, if my mouse works, move us into our Q&A portion of the show. So for our audience here, if you guys, I threw it in the chat, but if you guys want to answer or kind of pose any questions for Rob and Steve, submit those through the Q&A tab, and then I can pitch those out to the two of them for a few minutes. And I'm just going to take a look at what is coming through. And while we're seeing those, I'm actually going to take advantage of my host slot and ask the first question myself, which is really a little more high level, but how do you guys see that edge computing is transforming kind of the government and federal space?
I think it empowers decentralized decision making, right? Now you have people on the edge that don't have to send things back to analysts back in Langley or wherever they might be sitting to, dictate what happens downrange. They can actually make informed decisions in the field faster. And that, like I said earlier, that goes across not just DoD, but any entity that's doing any kind of edge collection. DHS with their border, right? EPA with their waterways. So I think that's the key is, how do we make people smarter but be mindful of the people that need to see the data as well. So everybody has to be working together. Kumbaya.
I agree. And it's what I see from edge computing, especially in the Fed space, is, it's easily deployable, right? Building a core data center, there's politics, there's costs, there's, it's time, there's things like that can occur where I can proliferate edge computing, and as long as I can get that virtualized view or the connectedness to take advantage of the edge computing, I can deploy it very, very easily, and I can put power into the hands of the people at these remote locations that aren't used to having something to help them in that environment, right? So, I agree with you. It completely changes things, but being able to get it in there quick and easy is extremely important as well, right? Things don't wait.
Yeah, and then dovetailing from that, you mentioned, okay, it's decentralized decision making is incredibly important there. How do you guys balance that with, say, maybe a need for centralized views or transparency of that data, say, particularly whether it's analytics or AI?
Good question.
Come on, I was trying to softball you here.
Playing stump the chump now.
We did say it was the hot seat. We did say it was the hot seat.
I'll let Steve take that one.
So, the balance is that it really doesn't matter, right? It's the fact that you have that flexibility to pick and choose and collaborate and pull them together in a way, even though they're geographically separated and there's different compute, requirements or capabilities, you're able to utilize it as one big holistic piece, right? So that, just like we don't want to force somebody into this particular cloud or this particular piece where the data is, we want to glue things together in management and leverage it as a whole, right? And I think the balance is that we've enabled that, right? Which then allows you the flexibility to say, what do I want to use, where, when, why, and how, right? I think the balance is just inherent to the flexibility.
Mm-hmm.
Yeah, and I think based on the question that just came across the line, we really didn't discuss cyber at all. But when you decentralized it, you had a lot of endpoints that were at risk, right? Because every endpoint became a target. And that's because every endpoint has its own file system and infrastructure. What we're doing here is unifying things for the storage administrator, at least, so that they're now operating from that higher echelon where they could push out cyber stuff from a single point of view instead of having to go out to each of these nodes that just are disparate systems and try to patch them all, right? So even though we're decentralizing, it's not in the same way as the old ways. And it's actually a much more robust architecture because now you're putting the storage control at one point, but the decision-making and all the architecture is distributed. So it's a whole different mindset.
Yeah, you bring up a good point. A lot of things from a security perspective happen because it's too complicated, right? I made the wrong choice because it's just too complicated, right? And being able to simplify and see everything, helps that, the old fat finger problem, right? Now it's a lot simpler. I can make decisions without trying to, overcomplicate things and potentially cause a problem, right? So yeah, good point.
Okay. Actually jumping on that as well, talking about kind of the security perspective. Are there any other kind of benefits from a security profile that adding Vicinity and Hammerspace can help with, whether that be more visibility of the data, not having to move it, not touching the data?
All of that, but also the ransomware equation, right? Your data assets need to be protected. Inherent to the Hammerspace file system are a lot of enterprise IT feature functionality. So we can do creative things like snapshot the edge and put it to the core, or snapshot and send it to the cloud. And then versioning and undelete and all these other feature sets that are often overlooked because they're too geeky to talk about in a 1 hour meeting, but they do really, if implemented the correct way, do give you a better protection mechanism against ransomware, because you can roll back, you can go back to snapshots, and your snapshots aren't on your device, they're somewhere else, right? So there's some inherent resiliency in the architecture that is often overlooked.
Yeah. And from our perspective, we're just the glue in the middle, but if I can secure that, through encryption or multiple versions of encryption or obfuscation, that helps us a lot. And we always tell people, don't break the security you have, enhance it, and make sure you're adding on extra capabilities that don't diminish what you already have. So yeah, good question.
Cool. And one more, I know we're running up on time here, to the both of you, kind of why is this solution exciting, whether it be from an edge computing perspective, from what it can do for AI, and what that means in the federal space, what that means for missions?
Well, I love this one Gartner analyst that came up with this term that the data center is no longer the center of the data. And that data is really mobilized now. It's a global asset, and companies are global, right? They're all over the place. Everybody we deal with is now dispersed. You just got to go to Costco and see all the people shopping during the day to figure that out. So I think the timeliness of what we're doing, the shift in things with the AI initiatives that are coming online, we're seeing investments within DOE right now. They're not going with the fancy file systems of like Lustre and whatnot, the legacy stuff. They're looking to the future on how to normalize things, and parallel NFS is one component of that. But then mobilizing, and how do we take all my HPC centers and start unifying that data? And that way, you can just do a whole lot more. And we saw that again with COVID. When we freed the data from its silos and started sharing more, data sharing became a thing. We got our fix really quickly. And I think that's why I'm so excited about what we can do here, and I think why it's relevant to the market today.
Yeah, good points. I'll just add that one little piece is that, this is one of those cases where everybody has this problem. My data is everywhere. I can't see it. I can't manage it. I can't get to it in time, right? I think the collaboration, the partnership that we've created here solves a specific problem that every single person I talk to has, right? And, that's what's exciting to me is, it's there. People are just dying for this kind of solution. So this is cool. I appreciate time.
So
nice.
You went dying after I brought up the COVID thing. You bring up dying. Come on, Steve.
Sorry.
It's okay. At least you were able to actually speak.
Emotionally.
And on that note, we're at time.
I know. On that note, we are closing. No, Steve, Rob, thank you guys so much. That's a great conversation. And I'm glad it is much more colloquial and a very, very important topic. How are you accessing your data, really optimize the management of it? So we're seeing that put to use in a valuable way. So thank you for sharing here, even in our safe virtual setting. For everyone on the line as well, really appreciate the time. We thought we would be fast, but we're still at an hour. So thanks for hanging out with us. If you've got additional questions, want to say hi to Rob or Steve or any of our teams, you can reach out to us. We've got all of the information here. We'll also be sharing out the recording, so you can reach out there too. Other than that, thank you, everyone. Have a great rest of the day. Watch out for the recording of this session, and we'll talk to you all again soon.